You know, for pretty much all of human history, making things has meant taking from the planet, digging, drilling, and leaving a whole lot of waste behind. But what if we could build our world, well, completely differently? Today, we're going to explore a revolutionary material that isn't mined from the Earth, but is actually harvested from the very air we breathe.
This one question, it honestly changes everything. We spend trillions, literally trillions of dollars trying to manage the carbon in our atmosphere. But what if we've been asking the wrong question this whole time? What if carbon isn't some liability, but is actually our most abundant, untapped resource for building the future?
Okay, so to really get why this new approach is such a big deal, we got to start by looking at the mess we're currently in. I'm talking about the twin crises we're all facing, our addiction to plastic and the carbon emissions that fuel it. And you have to understand, these two problems, they're totally connected.
For years, right, we've basically been stuck between a rock and a hard place. On one hand, you've got your regular petroleum-based plastics. They're made from fossil fuels, they pump out CO2, and then they hang around in our oceans for, centuries. Then you have the so-called bioplastics. Sounds good, right? But a lot of them compete with our food supply, they suck up huge amounts of water, and get this, many of them still don't actually break down in nature. So yeah, it's pretty clear we need a better solution.
And that better solution, well, it all starts with a radical change in perspective. It's time to stop thinking of our atmosphere as a giant garbage dump and start seeing it for what it could be, a mine. Yeah, a mine, floating right above our heads.
And that brings us to the main idea here, air carbon. Now, this isn't just about cleaning up pollution, it's about harvesting it. The technology literally captures greenhouse gases like methane and CO2 and uses them as the basic ingredients to create something brand new and valuable. It's a manufacturing process that's actually truly carbon negative. Think about that for a second.
So how on earth is it possible to turn a gas into a solid object you can hold in your hand? Well, the answer isn't some crazy, complex chemical process. Nope, it's a solution that has existed right here on Earth for billions of years. We're simply learning how to team up with nature's tiniest, most efficient factories.
So let's meet the heroes of this story, microorganisms called methanotrophs. These incredible little creatures are basically methane eaters. For eons, they've evolved to consume carbon from the air as their main food and energy source. We didn't invent this process, we're just finally getting smart enough to harness it.
Okay, so here's how it works, and it's actually pretty simple. First, in a big fermentation tank, these microbes get fed a diet of captured greenhouse gases and oxygen. As they consume all this, they naturally store the carbon inside their cells as an energy reserve, kind of like how our bodies store fat. And that stored energy, it takes the form of a natural polymer called PHB, which becomes the foundational building block for air carbon.
So we've turned air into a polymer. That alone is incredible, right? But for any new material, the ultimate test is performance. Can it actually replace the plastics we rely on every single day? Well, the data is, honestly, it's pretty remarkable.
Just look at this side-by-side comparison. In terms of performance, its tensile strength is right on par with polypropylene, a super common plastic used in everything from car parts to food containers. Its melting point is even higher. But the real story, the part that's just mind-blowing, is in those last two rows. The carbon footprint isn't just neutral, it's negative. And its biodegradability is high in both the ocean and the soil. This isn't just a replacement for plastic, it is a massive upgrade.
So what can you make with it? Well, the applications are incredibly versatile. It can be molded into solid objects like phone cases and cutlery, extruded into fibers for clothing, or turned into films for packaging. And here's the critical part. It can be processed using the same manufacturing equipment we already have for traditional plastics. That's a huge deal. It means we don't have to rebuild our industrial infrastructure from the ground up.
But let's talk about the ultimate test, the single biggest failure of the plastic age. Our oceans are just drowning in it. Any new material that claims to be a solution has to, above all else, solve this problem.
And this is the key to understanding air carbon. Because it's a polymer made by life, it's recognized by life. In nature, it isn't treated as a synthetic pollutant, it's treated as food.
This quote just says it all. If a product made from air carbon ends up in the ocean, it doesn't just stick around for centuries. Instead, marine microorganisms consume it, breaking it down and completing the natural carbon cycle. The pollution is simply reabsorbed back into the ecosystem.
You know, this technology offers so much more than just a better material. It points toward a whole new economic and ecological model.
A shift from an economy that just extracts and takes to a regenerative one, where we can actually heal the planet as we build.
And just think about the economics. Traditional plastic prices are hostage to the volatile oil market and global politics, but the cost of air carbon is tied to innovation and efficiency. As the technology gets better and better, the price will continue to fall. This could create stable, localized supply chains, allowing pretty much any nation with air to become a materials producer.
This right here captures the fundamental shift. For centuries, progress has been defined by extraction, taking stuff from the earth. This technology points to a new era of regeneration, where we create what we need by working with nature to reorganize the elements that are already all around us.
For centuries, we've built our world by looking down, digging resources from the ground. But maybe our greatest resource has been floating above our heads this whole time. The question is, are we finally ready to look up?